Okay, we are on video 2 for our flipped curriculum on atomic theory and structure. This is unit 4 in your notes. So if you look up in your upper right hand corner, it should say unit 4. Now we're about to discuss the periodic table and the organization of the periodic table. I can't emphasize enough how important it is for you to learn. This is one of our best resources. We don't really memorize as much as we do learn. And we need to memorize one thing. There are some symbols and names you need to know, but the goal really isn't to memorize it, but to learn how to use it and what the meanings are. So yes, there are a few things, but by and large, you want to learn to use this as a key tool. So let's take a look at that. This shows kind of an outline of the periodic table. And some things that you need to know as we're going through this are some of the names of the groups and families. Now, families, groups, we call them both, go this direction, so a group or a family. And a group and a family is going to have similar chemical and physical properties. Okay, just like you with brothers and sisters, if you have them, or if you know people who are siblings, especially twins, have very similar looks often, but not only that, they often have very similar temperaments and ways of acting and responding. Now, periods go across this direction, and we have 18 groups, depending on how you count them. They may not be numbered 1 through 18, but that's how we would count those groups there. And the periods are numbered down. So if we numbered down this way, and I want to show you where that little series, lanthanide and actinide series at the bottom shows up. So this would be 1, 2, 3, 4, 5, 6, 7, and this is going to be 6 and 7. Sometimes they're taken out here, sometimes they're taken out there. Really depends on the periodic table. And I showed you that expanded view before on that. So those are our periods 1 through 7 and our groups 1 through 18. Now there are some very important names and concepts that you need to learn from this, and we are asking you as part of your notes to color these in. So part of your grade on your notes is going to be to color these as instructed in the notes. And I'm just going to walk through a few of them right now. I've already mentioned the lanthanide and actinide series that Seaborg helped us pull together. We won't deal with too many of the elements down there, although you will see us work with things like uranium and every once in a while a few others, especially when we get to the nuclear chemistry portion. All right. Now, it's broadly divided. The upper portion is broadly divided by metals. So our metals are on the left by and large and take up the vast majority of the periodic table. So our metals would go all the way over to aluminum and gallium and over, and lead and tin. And we're going to talk about antimony and those in just a minute. So all of those would be our metals. Okay. Now, our non-metals are up in this area here. So here we have all of our non-metals. Now you'll notice again I'm kind of skipping a little staircase there. And I guess in the metals I should have included these little guys here. This one and this one. Now, so these are our non-metals. And you need to know that. It kind of breaks my heart over time when I hear people ask, especially by AP chemistry, now how do I know if it's a metal or a non-metal? Find a way to get that. Metals on your left, non-metals on your right. Then we have a group of elements along a staircase, and I got to make sure I didn't accidentally, and I did, color in a few of these, so we'll get these labeled in here for you. We have a group called metalloids, and that's boron and silicon. Aluminum is not considered a metalloid. Germanium is, as is arsenic. You can consider these little guys to be kind of bilingual. They'll speak metal or non-metal depending on their environment. And we'll tell you how we're going to name them, because when we name, we classify only as metal and non-metal, and polonium and AT. So there's usually a staircase darkened in along here. You can typically, most periodic tables will have that, where they'll put this staircase in here to help you delineate. It's important to realize, though, that aluminum is not considered one of these. Okay, so those are our metalloids, sometimes called semimetals. So semimetals. Both names are used on those. All right. Now, a couple of groups that are so alike, they end up having their own name, and we want to learn those. This group here is called the alkali metals. Alkali. Now, alkali, and let me talk about these two. These are called the alkaline earth. You've heard of alkaline batteries, I hope. So these are called the alkaline earth. Now, an alkaline solution is basic. And when these two groups are put into water, they chemically react to form a basic solution. Hopefully you remember, maybe dredging way back into 8th grade, that basic means that the pH is greater than 7, and acidic means that the pH is less than 7. So that's where they got their name, because they react with water to form basic or alkaline solutions. So make sure you don't mix those up, the alkali metals and the alkaline earth metals. Now, this whole group in here, this, and you know, some people, they disagree a little bit on some of the nuances, but for our purposes, we're going to call this whole block in here. So all of these metals in here, let me clean up this part in here a little bit for you. Those metals are called transition metals. Transition. So these are often called main group, and these are called main group, and these transition from one main group to the other main group. Okay, so you'll want to be coloring those as instructed in the notes. I'm just grabbing colors right now to describe, but you need to follow the instructions given in your note on that. Now, we have two more groups that have important names on the periodic table, and that's group 18. Those are called the noble gases. You can think of them like the nobility. They don't mess around with the riffraff. That's because they are inert. Inert, alert, alert. Key vocab word is inert. Inert means non-reactive. They're very stable. You've got helium and neon and argon and krypton, and by and large they're very, very non-reactive. So you should know what that word inert means. If you make flashcards, I would definitely recommend making a set of flashcards on these names that we're talking about here. Okay? Now, then there's one more group that you need to know the name of, a particular group that we'll see quite a bit of in this class, and I'm going to color them red. They begin with fluorine, go down to chlorine and bromine and iodine, and these are called halogens. Now, if you go on YouTube and search under Miss Kulkarni's name, you may be lucky enough to come across her song called Hallow Hallow, where she talks about the halogens. So this group is the halogens. Overall, these are the nonmetals. Specifically, we have noble gases, halogens. Overall, these are metals. In here, specifically, we have transition metals, the alkali metals, the alkaline earth, the lanthanide and actinide series. All right, so those are some things you need to learn, and I guess really do memorize about the periodic table. And if you do that, then the periodic table is going to be probably one of the most useful things that we ever give you on a test, and you are always allowed to have a periodic table on a test or a quiz if you need it. All right, I will see you next time. Until then, I'm signing off, and I'll let you figure out what YBCT means. Talk to you soon.